Thanks for having me. I'm really excited to be here. My name is Zach, and today I'm going to talk about how we can bring voice-first experiences to the web. So a little about me. Like the intro mentioned, I'm a bit of a multi-hyphenate. I build front-end applications, I do interaction design and product design. Right now I lead design at Hume AI, a New York City-based research lab building foundational speech and voice models optimized for human well-being. And I also teach a data visualization class at Parsons in the city. So when we think of voice experiences, I think the first thing that comes to mind often is Alexa or Siri. And these are experiences that are tightly coupled to a product ecosystem. And the really exciting thing about this moment in time is that LLMs are unlocking our ability to integrate natural language into our own apps that we're building today. And we've seen a lot of that activity over the past year. Apps like ChatGPT, Hume's app, HeyPi, Google Gemini, these all use LLMs to create kind of fun conversational experiences with users and also provide things like web search or other function calls that we're adding to LLMs. And there are a lot of benefits to introducing this new layer of voice onto an app. Talking is a lot faster than typing. I can speak a lot more words than I can type, typically. It also requires less technical literacy, so we're not traversing menus or learning how to use a certain form. We can just describe what we're trying to do. And it also enables multitasking and hands-free modalities. So this is great for accessibility because it kind of removes a barrier with some of that stuff. At the same time, it also comes with its own unique challenges. So it can be really difficult to use in public spaces where there's a lot of overlapping audio. Maybe things like an open office. Don't really want to be just like talking all day at your desk next to your coworker. And at this point, a lot of these apps also assume there's like a single participant in the conversation with the app. So if somebody chimes in the background, it kind of gets added to the context as if you said it. And so this also introduces the element of miscommunication. And so this can actually be slower than typing if you could just make sure that it's entered correctly once and not have to kind of like circle back and re-describe what you're trying to do. As these tools develop further, how are some ways that we can maybe bring this into our front-end applications, our browser-based interactions? So let's imagine a baseline UX happy path for how this works. We have a user, they speak into their microphone, and that audio gets translated into text using a speech-to-text system. We can then pass that text to an LLM to generate a new text-based response to our user. And then if we want to play it back as audio to stay in this conversational modality, we would use a text-to-speech system to turn that back into audio that's then played over the speakers to our user. And it's really exciting that there are new APIs being released and new browser-based features that allow us to start prototyping these interactions entirely within the browser, fully locally, not using any sort of network-based APIs. So in this talk, we're going to look at some of these tools. And we'll start off with speech recognition. So this has limited availability right now. I think primarily just Firefox is the straggler. This enables on-device voice recognition that helps us take that audio and turn it into text for our LLM. So as audio is streamed in, we have these events that we can listen to know when a phrase of speech started. So even if there's a little bit of silence at the beginning, we can know when the first sort of sound that is predicted to be related to speech occurs. And we can also tie into the end of a phrase of speech to know when the user has finished speaking. So what we get back is an object that contains a transcript with that text as a string, along with a confidence score for how accurate it might be. So we can start by instantiating a speech recognition object. And we can also customize the behavior of how we want this to work. So if we want continuous predictions of speech, for a conversation, it's not just like a one-off sentence. You might be taking turns. We can do the .continuous property. And we can also specify maybe a locale string for the language that the user will be speaking in. And then we can also tie into those events that get fired to update our UI, so we can show the user that our assistant is actively listening to them because we've detected speech. And at the end of the result, we can then pass that transcript to the LLM to generate a response. And once we have all those parameters defined, we can then manually trigger when speech recognition is turned on or off. So if you wanted to add like a pause button or a mute button, that's something that you can also control. So when this is triggered, it'll prompt the user for access to their microphone. And before you get to the conversational flow, it's probably a good idea to query for permission for the microphone first, just to kind of guide users through that experience rather than waiting until the very end. So once that's set up, we'll have the ability to collect all of these strings of text that's being spoken by our user. So the next part of this flow would be sending that text to our LLM. And for this, we can use this proposed API that is available in Canary Chrome. And it basically downloads an on-device version of Gemini Nano. So you can create a language model session. There is a Git repository kind of detailing this proposed API. It's also changed a bit over the amount of time I've spent preparing this talk. So I think it's still very much highly experimental. But especially for like proof of concepts or validating ideas, I think it can be a cost-effective way to get access to an LLM without having to pay like 1/10 of a cent every token or whatever. So to get started in Canary Chrome, if you search for the prompt API in the feature flags settings, you can flip that to enabled, and that will add this new property to the window namespace. So window.ai has a bunch of these kind of prompt API tools. And you can also check to make sure that the Gemini Nano model is downloaded correctly and ready to use by checking the .availability method. And it'll return this string that's either available or unavailable. So once we have that kind of checked, we can create a new language model session. And this is essentially like a brand new empty context to prompt against. So once we get that transcript back from our user, we can pass that into session.prompt. And what we'll get back is usually this, like, by default, really verbose, kind of almost run-on sentence from the LLM. And so this leads me into the next piece that we might want to customize, especially for creating like a branded experience, something that, we were just talking about someone building a Dungeons and Dragons like role-playing character. So this is where you could kind of customize the behavior of the LLM. So if we just want more concise responses, we can say like, no yapping, just answer the question. And then we'll get back an improved length of text. So at this point now, we have a good back and forth with our messages. We can hear what the user's saying, and then we can also provide responses. For a lot of these experiences, being able to have some sort of side effect or trigger some sort of functionality is useful. In APIs like OpenAI's SDK, Anthropic's SDK, they have a system of defining tool use. So you provide a schema for how the function should be invoked, and then the LLM will decide when the best opportunity to trigger it is. For the current state of the prompt API proposal, you would just do this by overloading the system prompt by describing the tool that you want the LLM to access. So here we're defining a play music function. We've kind of explicitly said like what parameters that we want, what types that we expect them to be. And this means that the LLM can then provide a response that starts with that specific string, so play underscore music in this case. And in order to get this to work in our client-side code, we do have to do some sort of manual parsing of those messages that come in. But providing we find a match, we can then extract the arguments for the function. And we can also intercept the response that's provided by the LLM so that in its own context history, it thinks that it said, I'm now playing this song by this artist, even though the response it provided was different. So this can surface better as like a message in our UI. Yeah, so we have LLM responses now. The last piece would be that we need to take that text as a response and play it back as audio for our user. So the last API that we'll look at is the speech synthesis API. So this is baseline widely available across browsers. And we could start off by making like a helper function called speak that takes in text. And this helps us kind of streamline two things that we need to do. First, we need to create a speech synthesis utterance. So this is an object that defines a phrase of spoken text. And then we can pass that to the global speech synthesis like playback queue. So it will ensure that it's not overlapping audio responses. It will wait for the previous response to finish playing before it speaks the next one. So we can trigger this synchronously without having to worry about waiting for like a audio-ended callback. We can also customize the voice that's spoken. So this is dependent on browser vendor and also operating system. And it's implemented a little bit differently across browsers, but we get a pretty extensive list. Honestly, a lot of these voices sound really bad. They're like some of the original voices from Mac OS. But in particular, the Google US English one, I think, sounds the best out of the box for Canary Chrome. So we can make sure that that's selected. And if we wanted to have the user choose their own voice and maybe like preview it, see if it's the one that they want to use for the conversation, I don't know, maybe you want like a heavily robotic sounding voice for certain use cases. We can use the get voices command to get that list of all of our voice objects. And in the example previously, I did filter by the browser locale. So there's also different language support across different voices for things like accents and pronunciation. So if we go back to that helper function we were looking at earlier, we could add this as an optional property. So if we pass in a voice parameter, we can define that on our utterance, and that's how it knows to speak that phrase with that voice. We can also customize the sort of way that that voice sounds through additional modulations. So we can update the playback rate, the pitch, and the volume. It's also possible to listen into those events to know when the audio has finished playing. So in our UI, we could surface buttons or signifiers of some sort to show the user that the assistant is no longer speaking. So now we've got all of our steps identified, kind of implemented. But yeah, it seems a little straightforward or maybe too easy. And I think one of the trickiest things about creating natural sounding conversations, especially with like AI systems, is that especially for like what we just looked at, it's very turn by turn. We're kind of assuming that the user will speak and then the assistant will speak, and the user will like patiently wait for their turn to speak up. And then also on the other side, with an awkward amount of silence, maybe the assistant wants to follow up on their previous message. So it's a little bit messier in reality than in the chart that I made. So it ends up becoming a lot more complicated, if the user talks while we're generating an LLM response. Maybe we want to ignore that response that comes in. Maybe this happens a lot. So it becomes really important to show visual feedback so that the user knows, am I in a listening state? Am I in a speaking state? Is it your turn to speak? And so from a design perspective, we can do that through these sort of visual signifiers. At the same time, something that I've noticed is that we're still really early in these types of voice interactions, especially with interruptions. A lot of people aren't aware that that's, we kind of underestimate their capabilities. And so even surfacing messages saying like, oh, you can like poke me to interrupt, or you can just like start speaking to interrupt, can kind of help guide that. So at Hume, we shipped this React SDK last year, and we're still kind of like iterating on it and building out certain things. But it works by sending a continuous stream of audio from your microphone, and then instead of doing speech recognition within the browser or trying to do the LLM response locally, it all gets processed by our API on our backend, and then we provide the events, the messages, the audio playback for you over a WebSocket connection. So it kind of handles all that state management stuff that we identified as being pretty tricky. Something that's unique to our conversational SDK is that we also provide speech prosody. So this is the like tone and like quality of the speech that comes in using our expression measurement model. And soon we'll also be integrating our latest model that we released. It's a text-to-speech model, but also speech-to-speech. And one of the cool features, in my opinion, is that you can kind of define a voice using a prompt. So if you want something that sounds like a medieval peasant or an ancient wizard or a shy cowboy, it will like generate what that sounds like for you, which can be kind of a fun element to it. So to drop that into your app, we have this voice provider that you can use to connect to our WebSocket, and then we provide a hook where you can get access to all those commands like starting a call, ending a call, getting a list of all of the messages that have been sent between the user and the assistant. And we also have this one-click deploy template where it kind of scaffolds all the bare minimum UI elements. So we have a waveform, we have a mute button, we have some data viz to show the expression measurement. If you build something with it, I'd love to see it, so feel free to reach out. I think it's really exciting, that we have the ability to add this new interaction model to our apps. As long as we're keeping track of, all these things. So that's all I have to share. Thanks again.